Good morning to one and all. This is Padmajyoti. Today I am going to discuss the topic Introduction to Object-Oriented Programming. Let us see objectives. First, initially, we need to understand what is object-oriented programming, understanding the principles of OOPS, and how it is different from procedural languages, the main problems with procedural language, and how OOPS overcome them, and also applications of object-oriented programming. So, let us see procedural languages. A program is nothing but a set of instructions where the execution of instructions will be in top to bottom approach. It will execute instruction by instruction. So, as the length of the programming increases, the complexity will also increase. So, in order to match with that, they divide the given program into functions or different modules. So that after merging all the solutions of the modules, they will get a final solution. There are few problems with procedural languages. One of the problem is functions have unrestricted access to global data. So whatever the data which is available globally can't be accessed easily by the function. So there are some restrictions there. And also they provide poor mapping to real world. So the objects which are real world entities can't be mapped properly with procedural languages. And also they are not extensible. We can't move this particular programming and run with some other platform. So it has some restrictions here. So these are the these are the problems with procedural languages. So for that reason, we came to a new concept called as object-oriented programming. So it is a programming paradigm which mainly deals with objects to build programs and also software applications. So we can develop different types of application with this OOPS concept. Like we can create some calendars, clock. These are different types of apps we are using in our mobile, and everything is modeled around real world. So the world we live is in full of objects. So objects are nothing but we can say a person, a thing, or a house. These are different types of objects which are available in real world. So we can with the help of these objects we can also create some applications with the concept of object oriented programming. Every object has a well defined identity, attributes, and also behavior. Objects exhibit the same behavior in programming. For example, as I mentioned, for example, I am considering that student is an object whose name is John. So student object contains properties or characteristics like name, age, gender, date of birth, etc. And similarly, if I consider behavior of a particular object, I can say eat, sleep, register, write exam, etc. So these are different types of attributes and also property of a student object. C, Pascal, Fortran are different procedural languages. So these are procedural language examples. Let us see with some OOPS language examples. The first OOP language is Simula. So it is developed during 1962. Later, with some overcomes, they move to other popular OOP language called as C++. So it has some, even though it is a popular language, but it has some restrictions. So they moved with Book, and finally they moved with most popular object-oriented language called as Java. So this is the subject we are going to discuss, deal in this semester. So object-oriented principles. With the help of these principles, we can avoid some sort of confusion with object-oriented concepts. So these are different types of principles like object, class, inheritance, polymorphism, abstraction, and also encapsulation. An object is a real world thing or an entity that is tangible or intangible. So an object consists of properties and also behavior. If you consider here, there is another definition called as it is defined as instance of a class. For example, table, chair are all on instances of the class called as furniture, where furniture is a class, table, chair, these are all called as objects. So objects have unique identity, state, and also behavior. So every object has different behavior and different characteristics. So state is defined as attributes of an object. As I mentioned, for a student, there are different types of states are nothing but roll number, name, age, date of birth. These are different types of attributes which are called as state. Different objects have different types of attributes. It may vary. For a student, roll number, name, these are objects. If you consider an object as a chair, then you can consider width, the height, the type of wood. These are different types of attributes. Let us see the next principle called as a class. Class is defined as a blueprint for an object, or it can be defined as a template or a plan. So which is nothing but, if you consider here, this is an example, the yellow one, which is defined as a mold here, or a template for creating objects. With that mold, we can create some different types of objects. The blue color, the blue object, which is nothing but is called as which is an object here. So considering the, if you consider the above student example, I'm considering that there are three different student objects like John, Mary, and Krishna. All these students will have some similar properties like name, age, gender, etc., and similar behavior like register, write, exam. These are different types of object for a class student. So for a class, there can be of any number of objects. So description of a number of similar objects is known as class. So it is a new data type, which is generally user defined data type. So how to create class and how to create objects, that we are going to discuss in further units. Defining a class doesn't create an object. So for example, there is a class called as furniture. So creating a class doesn't create an object. So we need to explicitly create an object. For example, furniture do not have any existence, but tables and chairs have existence. So this is the best example for defining class and object. So let us see some more examples. Here phone class. Phone class, it consists of different types of objects like a landline or a cellular mobile, a normal smart mobile. So these are different types of objects for a class phone. Similarly, if you consider vehicle class, there are different types of object like scooter, bike, bus, ambulance, or truck. These are different types of objects in a vehicle class. And if you consider another example, here there is a girl. So I'm considering this is an object. So object consists of both properties and also behavior. So a property is nothing but it is considered as a characteristics. So here for a particular girl, the characteristics here I'm going to use are height and weight. Whereas if you consider behavior or function or a method, which is nothing but it actually determines the way an object interacts with other objects. Means, for example, this girl has some behavior like singing and dancing. How this singing and dancing is different from other girl or other boy. So this is nothing but behavior. It actually determines how it interacts with some other object. Sorry. So, and this is one of the representation of object and a class. Here John is an object name and student is a class. So this type of representation can be done using industry standard language called as UML, Unified Modeling Language for Student Objects. So this is how we can represent a student. So generally we are going to represent objects and classes in UML. Okay, so let us move with another principle called as abstraction. So abstraction is one of the first of the orientation principles. It is defined as hiding the complex details and presenting only with the relevant or necessary details. So it mainly used to manage the complexity by abstracting details. If you consider abstraction can be implemented with the two concepts called as encapsulation and also inheritance. So abstraction is defined as hiding the complex details and presenting only with the relevant or necessary data, as I mentioned. Let us move with an example. For example, if I consider a car is an example. So before going internally with this, let us consider in detail with simple. When you want to purchase a car, the car dealer will use the details of available colors, seating capacity, engine, gearbox, type of steering, and some other general details. The car detailer never tells you specific details of material being used for the hood, nuts and bolts and so on. So here the car dealer will hide the details which are unnecessary for you. So this is called as a concept called as abstraction. So let us see in detail here. If you consider you as an entity, you know how to start a car by pressing a button, and you don't know how internally it is working. So this is called as an abstraction for you as an entity. If you consider local mechanic as an entity, local mechanic will have some knowledge how implementing the starting of the car. Like he can open bonnet and check the battery cable or chalk, etc. But you don't know the exact implementation of the car in detail. So it is also a sort of abstraction is available with local mechanic entity. But if you consider expert entity, since he is a designer of the car and he know most of all the operations of our car, So he can repair very quickly. So in short, expert entity knows all the implementation of car. So there is no abstraction here. You know everything. Nothing is hidden here. So this is an example how a car works with the concept of abstraction. So this is using abstraction. Just we know how it is working. We are not going in detail about internal details. This is without abstraction. Here, and the thing is known to us. As I mentioned, we can implement abstraction with the concept called as inheritance. So let us see. Inheritance is nothing but the classes are arranged as hierarchies. You might come across situation where even though objects have similar properties are quite different, in such cases, it is better to move all the common properties and behavior into one common class and specific properties and behavior into special class. So this is called as the concept of inheritance. So which is nothing but it is a mechanism in which one object acquires all the properties and behavior of parent object. So if you consider here, this is the parent object and this is a child object where a child will inherit the properties of parent class. So there may be of some common features in between them. So those common features are inherited to the child class. So this is a clear picture of inheritance. So it mainly consists of two classes. One is base class, another one is subclass. It maintains a parent and child relationship, as I mentioned in the previous example. A subclass inherit all the properties of base class. In addition to that, it may have some own properties. Properties are nothing but we can say that properties, or you can also call it as behavior. So this is another example where vehicle is a main base class. From that vehicle, you can have some other subclasses, road vehicle, air vehicle, water vehicle. Again, from that, you can have again subclasses. So bus can inherit properties from road vehicle. Indirectly, it may inherit properties from vehicle. Similarly, other examples also. This is also another example. Here, animal is a base class, and this is a subclass where we inherit properties from base class and derived class. Now let us see another way of implementation of abstraction, which is nothing but encapsulation. So encapsulation is defined as wrapping up or combining the data and code into a single unit, where the code refers to variables. The code refers to methods and data refers to variables. So every object contains private data and public members, which allows to access code to other private data. So we can see that private data, public methods in detail and further. Let us see what is encapsulation. So it will binding of data and procedure. So where we can restrict accessing of data directly. So it is called as data hiding. So this is example of encapsulation. Here we are binding data and also procedure. So this is how to accessing the data. So in order to access the data, there are different types of terminologies like accessing permission, like public, private, protected. So based on the access modifier, we can access the data. So these are this is one of the represented. This is an object. An object may consist of private data variables, private methods, and public methods. So let us see this with an clear example. For example, as a real world entity, encapsulation can be considered with an example called as television. So we access the television by using a remote, which provides an interface to communicate with the television. So the television manufacturer is hiding its components, which is called as data, under the shell, and it is providing public interface to access its components. So we can directly access the TV, but the internal how it is working, how we can access with that interface is not known to a particular user. So this is the best example of encapsulation. And if you consider another example, as a driver, you know how to start a car by pressing the start button. And coming to internal details of starting operation is unknown to you because you don't know how, if by pressing a particular key, how it is working. So the not necessary data is hidden from you. This is an example of encapsulation. It is available, but it is not known to you. And next object oriented principle is polymorphism. So polymorphism means having different forms. For example, if you consider an example of a particular boy there. So depending upon the situation, and suppose he is in a shopping mall, he behaves like a customer. If he is in a bus, he behaves like a passenger. If he is in a school, he behaves like a student. Like that, depending upon a particular situation, he may have some different types of forms. So let us move with an example here. Based on the situation or different factors, the same thing exhibits multiple behavior. So this is called as, in generally called as polymorphism. For example, certain bacteria that exhibits more than one morphological form. A bacteria, depending upon the situation, it will exhibit in different types of formats. So we can see some one more example here. So let us consider the animal chameleon. This animal changes its color to reflect the surrounding to hide from its prey. It is really cool. Based on the color of the surroundings, the same thing, Chalaman, can change its color from one form to another form. So this is the best example of polymorphism. So an object may have different types of formats depending upon the particular situation. So you can implement these concepts in Java. And let us see in detail polymorphism here. Here this is state. Mobiles with different colors means having different forms, and similarly mobiles will have different type and different model. But if you consider the behavior is everything is same. Means the mobile will ring, the mobile may receive SMS, the mobile has some clock features like that. So these are some behaviors and states of a particular object. And now it's your turn. So try to check what is a class, what is an object, and what are the various object oriented principles. So if you are having any doubts, you can go through the video, or you can approach me for further clarification. And let us discuss some more gate questions. Which is which of the following is associated with object? A, state, behavior, identity, all of the above. S, everything is associated with object. A state, behavior, identity, as I mentioned in the first slide. So answer is all of the above. And coming to the next question, the feature in object oriented program that allows the same operation to be carried out differently depending upon the object. So inheritance, no. Polymorphism, why it is not inheritance? Inheritance is nothing but having multiple forms. No, inheritance is nothing but acquiring the properties of base class is nothing but inheritance, whereas polymorphism is nothing but having different forms. This is nothing but, the particular answer is nothing but polymorphism. Why is it is having multiple number of forms? So answer is polymorphism. And let us see comparison of object-oriented programming and procedural programming. So debugging is very difficult in procedural language, whereas we can debug easily. If there are any errors, it is easy to identify in object-oriented programming. Where encapsulation of data and methods available in OOPS concept, it doesn't have any encapsulation. And the one of the main advantage of procedural language is nothing but it is faster compared to OOPS concept, and it is less flexible. We can't further move it to some other environment. Procedural language is less reusable, whereas object-oriented program is more reusable. So only data and procedures, means only data and functions are available in procedural languages, but whereas the OOPS concept like inheritance, encapsulation, polymorphism are the main key features of object-oriented concept. As I mentioned, procedural language works with the concept of top to bottom approach, whereas object-oriented programming works with the concept of bottom to up approach. So only a function call to another. As I mentioned, for example, C is a procedural language where a function will be called only by some other function. Means main will call some function addition or subtraction like that. Whereas in object-oriented language, object communication is there in between objects. So examples are C, Basic, Fortran, whereas object-oriented languages are Java, C++, C hash. Those are different types of procedural languages. And coming to applications, these are different types of applications like you can use in artificial intelligence, neural networks, database management system, and it can also be used with the different developing of different types of applications like music, chat, calendar. So these are different types of applications we can prepare with the help of OOPS concept. And in also real world, we are going to use this concept with like automatic working of an automatic car or stock exchange. So these are different types of applications that we can use with the concept of object oriented programming. So with this topic, I'm going to wind up the concept introduction to object oriented programming.